Hello everybody. Today we want to look at the relationship between changes in oxidation state and redox reaction. First, it is important that we look at the definition of oxidation state. So if you establish the definition, then we will relate it to redox reaction. So in the definition, we have some important terms. Number one is number of electron lost, and also number of electron gain and number of electron shared. And if you remember redox reaction, it is also about electron gained or lost. So it means we can relate oxidation state to redox reaction. But how do we do that? So before we can get into that relationship, we need to understand some rules for oxidation states. So instead of going to the rules directly, I prefer to use some examples to establish the rules. So if you look at those examples, then we will get what the rules mean from those examples. So I will start from loss of electron in sodium atom. So let's look at this reaction. Remember, sodium is element number 11 in the periodic table. So it means the electronic configuration of sodium is 281. And that this one means the last shell has 1 electron, which means sodium has the ability to lose 1 electron. So if you write the reaction for loss of electron in sodium, it's going to be Na minus 1 electron to give us Na plus. So in this reaction, we have two species. We have sodium atom and we have sodium ion. And then you can see that sodium ion has a positive charge, but sodium atom does not have a charge. So we can put 0 here to show that sodium atom does not have. Now, going back to the definition of oxidation state, said number of electrons an element has gained or lost or shared to form a compound. Na atom, it has no charge because of this 0. So having no charge means sodium has not lost any electron at that point in time. And sodium is an atom, or I can say an element. This one will be our first rule of oxidation state, that oxidation state of an element that has not combined with any other element is gonna be 0. So for sodium like this, because it has not lost any electron, its oxidation state is 0. So any element in the periodic table will have oxidation state of 0. This one is extended to molecular element as well. That is, if I have this list, Fe, I have Cl2, I have H2, I have helium, I have Br2, I have Mg. These are elements. Some of them are single atom elements, some of them are molecular elements. So whether it is a molecular element or just a single atom element, its oxidation state is going to be 0 when it has not combined with any other element to form a compound. But when sodium lost an electron, what happened to the charge of sodium? We can see that the charge changes from 0 to +1. So it means the oxidation state of sodium ion is different from that of sodium element. So we can establish another rule of oxidation state. That is, oxidation state of any ion will be the charge on that ion. So for sodium ion now, which is Na plus, its oxidation state is +1 because the charge of sodium ion is +1. So it means we can predict the oxidation state of chloride ion. So and that would be what? So it's going to be -1 because the charge of chloride ion is -1, which is the charge on this ion. Now let's look at the reaction between sodium and chlorine to form sodium chloride. So we're going to use that reaction to establish another definition, another rules for oxidation state. Now, of course, we know that this is an element. It is also an element, but it is a molecular element. But here we have a compound. And then we've established that the oxidation state of an element is going to be 0. And for this, it means it's going to be 0 as well. But what about this sodium chloride compound? What is going to be its oxidation state? Now, before we can establish the oxidation state of sodium chloride as a compound, we need to look at the atoms or the ions that formed the sodium chloride. Remember, we can split this compound. We can write it as Na plus in the Cl minus. So it means sodium ion and chloride ion, they combined. That is why we have sodium chloride. Or let me say, sodium chloride is just an attraction between sodium ion and chloride ion. Now, and then the charge of sodium ion is +1, and that of chloride ion is -1. So, of course, we can predict now the charge of sodium chloride. So, what is going to be the charge of sodium chloride? Of course, if it says 0, it means you are correct. So, it's going to be +1 -1 to give us 0. And this is the establishment of another rules for oxidation state. The oxidation state of any compound is going to be 0. Why is this 0? Because it is the sum of the oxidation state of the ions that form the compound. So that is why we have oxidation state of sodium chloride to be 0. So I can just put 0 here as well for the compound. So we have 3 rules now. The first one is oxidation state of an element. We said it's going to be 0. The second one is the oxidation state of an ion. We said it's going to be the charge of that ion. And the third one that we just got now is the oxidation state of a compound. We said it's going to be 0. Now, if they ask you, what is the oxidation state of sodium in sodium chloride? Or they ask us, or they ask you, what is the oxidation state of chlorine in sodium chloride? So, of course, you know that sodium chloride means Na plus bonded with Cl minus. So sodium here is Na plus, it is sodium ion, and chlorine here is, that is sodium in sodium chloride is sodium ion, and chlorine in sodium chloride is chloride ion. And what is the charge of sodium ion? It is +1. And what is the charge of chloride ion? It is -1. So the charge of sodium in sodium chloride is +1, and the charge of chlorine in sodium chloride is -1. You understand that? That's good. So let's move. I have another example here. I have Al2O3, magnesium oxide. If they ask you what is the oxidation state of this compound, of course it's going to be 0 because it's a compound. So, but why is it 0? Because we have 2 aluminum atom and 3 oxygen atom. This one may not give us 0. So let's just show you how we got 0 for that. Remember, the charge of aluminum is 3 plus, and for oxygen is 2 minus. So just multiply these 2 by 3 plus, we are going to get +6, and then we multiply 3 by 2 minus, we are going to get -6, and then we give us what? It will give us 0. So that is why the oxidation state of this compound will also be 0. Of course, for any compound, the oxidation state is going to be 0. Before we go, we have some other issues about the rules of oxidation state to clarify. It is about transition element. transition element, that the element in the middle of the periodic table. For example, if this is the periodic table and have this, and then we have this lanthanide and actinide series. So the element here in the middle of the periodic table here, and those outside here, they are transition elements. So what is their oxidation state? Yeah, of course, when we say transition element, it is an element. So as an element, its oxidation state is going to be 0. But what about its ion? Let's look at this compound. We have copper 2 oxide, and another compound again of copper 1 oxide. From this name, we can know the oxidation state of copper. Here they said copper 2, so it means the oxidation state of copper here is +2, and the oxidation state of copper here, because they said copper 1, it is what? It is +1. So it means copper has 2 different oxidation states. One of the properties of transition elements is that they can have more than one oxidation state, and we can usually know them from the name of the compound. So when they say copper 2 oxide, it means the oxidation state of copper is +2. You cannot hear magnesium 2 oxide, you can only hear magnesium oxide. So it means magnesium has only one type of oxidation state.